Hi, Eduardo.
Hello, how are you?
I am good. So, yeah, welcome to Open Source Spotlight. Can you tell us a few words about yourself and about the tool you want to show us?
Yeah, absolutely. So I'm the co-founder of Bloomberg. We are developing open source tools for data scientists. We want to make it simpler for people to develop, deploy, test their data science projects. And today I'm going to show you and show all the data talks community the most recent project we work on, which is called nbsnapshot, and it allows you to test notebooks.
Yeah, that's, I guess, one of the things when people say why they don't like notebooks. One of the first reasons they say they don't like notebooks is because it's difficult to test. It's not possible to test, right? And today you will show us that it actually is possible.
Yeah, one approach. I'll also mention a few other approaches because I think we need to see the big picture. But this has like some specific use cases, but still testing, not unit testing. I would say it's more like integration testing.
Yeah, let's see.
All right, let me share my screen. Now, can you see my GitHub page?
Yes.
All right, so this is the repo. In case you want to try it out, it's Bloomberg NB snapshot. And please show your support with a star. And you'll see the documentation. We have a blog post with more details. The README is pretty short, short and to the point. Instructions to install it, link to the documentation, a few example use cases, and some simple example that you can run to get things, to test things. Okay, so let me show you what this thing is about. First, I have Jupyter here. I'm going to open my terminal. Let me look at my notes so I know what's the order of the examples I want to show. Okay, so let me go to this folder where I have the most basic example. So we start from like the simplest possible thing. So let me open here, examples, this one. So the most simple example that I can show is a notebook that prints a number. That's the only thing it's doing, right? It just prints 10. Now, one of the things that make testing not only notebooks, but data science code in general is that the outputs are not always the same because the performance of your model may change, because there might be some randomness, or the data may change, right? And this is what we want to achieve with nbsnapshot, to create a more robust way of testing things. But let's stick with this simple example for now. This is not going to change. It's always going to produce 10. So you have this simple notebook. Now, if I come here to the command line and I do nbsnapshot test, and then I pass the path to the notebook, type nb, and then I say run. This is optional because you may want to test the existing outputs. In my case, I want to rerun the notebook and then check the outputs. So if I do run, it's gonna run the notebook and then check the output. Actually, the first, so you can see that it's saying metric is okay. And if I run it again, it's gonna run the notebook and still a constant number, nothing is changing. So metric, okay, that's how it works. Now, a few details. nbsnapshot does not test all the outputs. What you have to do to tell nbsnapshot to test something is to add a cell, a tag to your cell. And if I click here, you'll see that I have a cell called metric. That's why nbsnapshot is testing this one, but I have something else like.
How does the test work? So it executes the input and compares that the output is in the notebook is the same as the cell produces, right?
That's a great question. Not exactly. It creates this this JSON file. You see it here. And every time you run your notebook, it stores the output. And then it compares the historical values to the one that it just got from the current run. Now, this is important. In this simple case, I'll show you another example next, but in this simple case, all you have is 10, 10, 10, 10. So next time you run it, it will be like, yeah, this is the same output that I have, so no issues. Now let's move to a more complex example. Where
just wanted to understand this one. So you add a tag metric to a cell, and then you execute it once, and then you save the value to this constant.json file, and then you execute it one more time, and this time when you execute it for the second time, then you can compare that the previous run and the run you just had produce the same output, and then the test passes, right?
Yeah, exactly.
Okay.
Now let's look at a more complex example that has, let me look at, I think here. Yes, this one. So this has a few more things. Now, what I'm going to do, this first chunk of code is not important. It's just setup. What I'm doing here is I am creating an existing history, like a notebook historical records, and saying that I have a notebook that generates a random variable. You can see it here. And it's actually 50 times. So this is just to simulate that I ran my notebook 50 times before. So let me run it now. And it takes a parameter. So I'm going to fake this notebook that has a cell that draws a normal variable with mean 10. And then I can plot the history. And you can see it here. This is the history of my cell. Like we can assume this is the metric of our model. And you can see that most values are around 10 because it's a normal distribution. Now let's see what happens if I run this, which is going to run the same thing that I ran on the terminal with a notebook that prints the number 10. So it's the same exercise. You see, saying it's okay because it's 10. It's like within this range. So it's expected. Now let's see what happens if I fake the history of my notebook, but now I change from mean in number 10 to a mean of value 0. So I'll rerun this function. And now you see the historical values are around 0. Now let's see what would happen if I run a notebook that prints 10. Now 10 is like over here, like really different, like an outlier of what I've seen in the past. If I run this, it will say it's too high. It's not expected. Now, how do I compute this range? I take the it's 3 standard deviations from the historical values. It's currently, you currently cannot change it, but I'm working on it so you can switch this threshold depending on your use case. But right now it uses 3 standard deviations to determine what's the appropriate range. In this case, it's telling you 10 is too high. I was expecting something between -3 and 3. And that's how it works. So the most, I think I would say, well, first of all, before I move on to the next example, any questions? I think you're on mute.
I am, yeah. So I'm just wondering, how does constant.json look like?
Oh, I can open it. Let's see.
So what you did there in the notebook is you created this constant.json file. So when you run compared, was it compare.run or something like this? I don't remember. Then actually internally you look at this constant.json file, and then when you compared the output, it was 10. It didn't look at all like what you have in the JSON file, right?
Exactly. And you can see it here. This is a representation of the history, right? It's all around, like most numbers are between -2 and 2, and the current output in the notebook is 10. So nbsnapshot is like, this is something completely different. You better check it out. It's not telling you why it's failing. It's just telling you that something's off.
Okay.
Okay, now we can also test images. So let me show you here. Should be here. Okay. So the sample notebook prints an image, and we can also test those. Now it's different to test a number from an image, and it's a bit more difficult, but essentially what we are doing is comparing the pixels. It's a really simple way of testing things, and maybe you have some, I think one good use case is when you have a library and your examples are notebooks, and you want to check if the changes that you made to your example, you run the notebook and it may create new plots that are unexpected. Maybe the labels are off, maybe the axis, that kind of thing. So this allows you to test those changes. All right, so now I have my sample notebook. And the first time I run it, it won't test anything because it just stores the image. So it's telling you, let me actually delete the existing history because I ran this before. So we start from a clean state. All right. So now the first thing it will do is telling you it's adding the image to history. It cannot test anything because this is the first time the library has seen this image. Now, the next time, the only thing that it can test is the dimensions of the image. So that's why you see that it's testing the image size. So if your image had like 500 pixels by 500, and then next time it has 500 and 600, it will complain. But it doesn't know how much variable this is, and that's why it's only testing the size. Now, if I run it again, it will record another time, and now you have 3 data points, right? With those 3 data points, what you can compute is the difference between the first one and the second one, and the second one and the third one. And that gives you a measure of how much variability there is in your image. So the next time you run it, it will actually start measuring the difference. And now it's telling you it looks okay. Now let me go and change this. So we force this.
Maybe can you show how JSON file looks like? I'm just curious.
It's storing the image in base 64.
Okay.
It's encoded.
Makes sense.
It's not readable.
Mm-hmm.
All right, now let me change this and do something like, so this was 1 to 3, now let's do 3 to 1. I need to run this first. Okay, now let's run it again. Now it's telling you it's failing, because, and you see actually, since all my executions had the exact same image, it doesn't expect any variability. So it's telling you, I'm expecting a difference of 0, and now you have a completely different image. And that's why it's complaining. Now, my last example is like a more complete example. Let's see a machine learning notebook. So now it's kind of the same story. The first thing I do is I download a notebook. And let me see if I have it here. Let me grab it from here. Should be this one. Now, let's first take a look at this notebook. It's really simple. Actually, the details are not that important. I'm just loading a sample data set. Then I train a model. Then I feed the model. And the value that I'm tracking, that I'm testing, is the accuracy. And that's the last output. So let me download this one. Open a terminal. Okay. Now, the first thing I'm going to do is I'll run the notebook 10 times. So imagine you train your model a bunch of times, and you keep iterating on your notebook, so you create some history. So the first time it doesn't have any references, so it tells you, I need one more to start testing. And now it started testing. In iteration number 2, it's telling you, I checked the accuracy, looks good. And we'll see, it may fail because depends on the variance of our code. But let's see what happens. It's almost done with the iterations. And then we are going to look at the history to see how it looks like, the ML classifier JSON.
Mm-hmm. So every time you run something and test, you still write to the JSON file, right?
Yeah, yeah, exactly. Now let's look at the history, and now let's plot it. So this is the performance of our model. So you see that most values are between 0.94, and this is like 97. And we have some like outliers, like 93 here, 99, but these are the expected values. Now, let's manually compute the range, because I explained before that we use 3 standard deviations, and this is what we would expect. If we train our model again and the accuracy falls inside this range, then it's not going to complain. If it goes, let's say, like 0.85, then it will complain. Now, this range is long enough, and it also hints us that there's some variability in our code. So it's actually good to keep this history, because there's something going on with our code. And I think it's because I only have a single tree in this. Like I on purpose created this variability. No, it's actually 100. So it's probably because of this, of the shuffling of our data, why we have this. And And that's it. So that's how nbsnapshot works. We are adding a bunch of features. We see currently three main use cases. The first one is you have some example notebooks that you want to test, and you want to test them every time you modify those notebooks. The second one is you have a model that you are retraining. It doesn't have to be a machine learning model, like anything that you are measuring, a metric. You want to make sure it doesn't deviate too much. And the final one is you are scheduling a notebook and you have some metrics about your data. And if your data looks off, then you want to know and you want to stop execution, because maybe you are generating a report for someone. And if your data looks different, then it's important for you to check what's going on.
And I'm just curious about the best practices. Let's say we think about the third use case. It's a scheduled notebook. And so we run our notebook and we, I guess, update our JSON file, right? What do we do with this JSON file? Do we commit it back to Git? Like, do we have to keep it up to date, right? So we have always be appending to it.
Yeah, that's a good point. So right now, the only storage that we support is this JSON file, but we are working on adding support for an external database, for example. Instead of saving to a local file, you store in a database. We actually have an example in the documentation that shows how to use GitHub Actions. So you run the notebook, and then you store the new JSON file. But that's a good point. In some cases, if you're testing maybe one or two metrics, it's fine to commit the JSON file. But if you're testing like 5 images, then it's not like a great idea to have that JSON file there.
You don't want to keep appending the base64 encoded thing to your JSON file, right? In every time you run your CI/CD job.
Yeah.
Why did you decide to make it? Like, what was? Did you want to have some tests for your documentation, or it was something that you saw that your customers, people who use Plumber, that like they had this problem?
It's both. So actually, so it came from two sides. The first one is we have a lot of examples in notebooks, and the only testing that we do currently is to make sure that the notebook runs, but we are not testing the outputs. So that was the first one. The second one is that when we talk to members of our community, what they tell us many times is that it's hard to set up an experiment tracking thing. And in many cases, like in some cases, it makes sense to have a full-fledged platform for experiment tracking. But we realize that many of our users have a simple use case, and they just want to know if there's something off with their notebooks. And that's how we came up with this idea, because they are like, yeah, the notebook changes, but that's normal. It's normal that it changes from one day to the other. And especially because of the scheduled notebooks, we have many users that run Plumber pipelines that run an analysis with a new batch of data. So the metrics, the plots look different, but they shouldn't look so different. So the only thing that they have to do is add nbsnapshot, and that's it. They don't have to add any infrastructure. They keep using Plumber, and they just add this new thing, add a few new tags to the cells in the notebook, and that's it.
And I guess now I kind of understand why the name is nbsnapshot. So because every time you run, you create a snapshot, like you capture the output of the cells, and you put this output to the JSON file, right? So it kind of creates a snapshot. And then what you do is you compare this snapshot with the previous snapshots, right?
Yeah, exactly. And actually, it's a fun story, because the idea, like the aha moment for this, I was talking to a front-end engineer and who doesn't know anything about notebooks. And I was telling him this issue, like, oh, it's really hard to test notebooks. And when I was explaining the idea, he told me that sounds like snapshot testing for JavaScript. And then I looked that up and I found that people, like, it's the same problem, because front-end engineers have to test user interface. Like, how do you know if your button is off, like it moved from one place to the other? They do the exact same thing. They record like how the user interface looks like. They take a snapshot, and the next time they run the tests, they check with the previous snapshot. And I was like, yeah, we can apply the same idea to notebooks. And it's called snapshot testing. So I just took the same name.
That's actually the first time I hear about these concepts, because I guess I'm not a front-end engineer either.
It's
Yeah.
really interesting. Like it's really
Yeah, it is.
clever how they test things.
So what are your plans? What's next?
I think right now, now that we released this first version, we want to keep talking to more people. There might be some other use cases that we haven't considered, and then there are also a few things that we want to add to make the usage simple. So yeah, just talking to people that are interested, talking to users, and then adding a few more things, and then making a full integration with Bloomberg, because right now they are like two separate tools, and it requires some configuration. So we want to make it simpler for both tools to work together.
And if somebody wants to contribute, what's the best way for them to do this?
We have a couple open issues, but I would say the best way is join our community. You can find all the details on the README, and you can ping me if you want to contribute with some example, or I have some ideas. We are always open to that, because it's pretty empty right now, the GitHub. I have a bunch of things that I want to do, but I haven't uploaded the list to GitHub, so it's not public. But I'll do it at some point. I think for now, the best way is just to contact me.
Okay. Do you have any advice for anyone who is watching this?
In terms of using it, in terms of open source?
In terms of everything, like, I don't know, life advice, open source advice, Bloomberg advice, and nbsnapshot advice.
Well, that's a lot of things. So I'll keep it brief, and I'll say, I mean, my only advice is for people to, like, who are doing data science, to get involved into open source. Like, you learn so many things. And if you have an idea, even if it's crazy, just do it. It's fun. I had a lot of fun implementing this thing. So yeah, I think many people are afraid of contributing to open source because they think, oh, it's like really hard and you have to be like super expert at programming. Not really. Just do something that kind of works, then go and show it to people, get feedback, and make it better. Like, people understand that you are putting your time to do something, and they understand that, and they are willing to help you. And there's many ways to help. Like, some people may contribute to your project, some other people may give you feedback, some other people may go and tell their friends about what you're building and bring you more users. So just go, like, you have an idea, go and build it, and you'll have fun. I think that's the advice that I want to share.
Yeah, great advice. Thanks a lot. Thanks for doing the demo. Great demo, great tool. And yeah, I guess looking forward to seeing you here one more time. Maybe you'll have you'll talk to, I don't know, maybe some different front-end engineer, and they will share something else with you, and then you will go and follow your own advice, build it, and share it with us.
Yeah, I'll keep bringing ideas from other areas to the data science tooling.
Yes,
I think that's been working well.
Okay, thanks.
Yeah, thanks.